Okay, so the next question we have here is an investing math question. Harry wishes to invest $2,800 into a savings account at his bank. His bank offers an interest rate of 5.96, compounded semi-annually. So I'll just write that down. He invests $2,800 and the interest rate is 5.96%. And then compounded semi-annually. So I'll just write semi for semi-annually. And then Harry's friend, Ida, invests $2,000 into a savings account at her bank. The bank offers her an interest rate of 7% compounded semi-annually. So they're both compounded semi-annually. She has $2,000 and then 7% is her interest rate. And then the question asks, after how many years will Ida's investment be worth as much as Harry's? So what we need for this equation is kind of the equation for interest rate and linking principal amount to the total accumulated amount. And that equation is as follows. A equals P times 1 plus R over N to the power of N times T. So A is the accumulated total value. So after that period of time, A represents the total value that we've accumulated. P is the principal amount. P is what you've initially invested. So in this case, it's $2,800 for Harry and $2,000 for Ida. And then this is just the one, and then R is the interest rate. So whatever the interest rate given here. So it's 5.96 for Harry, 7% for Ida. And then N is the number of times the amount is compounded per T, per time period T. So T is usually represented in years. So because T is represented in years, we know that semi-annually gives us N equals 2, because for each year, the amount is compounded twice. And then for T is what we're trying to solve, because that's what the question is asking. After how many years will Ida's investment be worth as much as Harry's? And we want to see at what point will let's add two more variables. So we'll say AH is equal to AI. So at one point will AH equal AI? So we can clear some space here. And we'll write out as follows. So we know AH is equal to the principal, which is 2,800. Let's double check. Yep, 2,800 for Harry. And then we have times 1 plus 0.0596. And then divided by 2 to the power of 2t. Oh, that's behind the camera here. So that's for Harry. So I'll just write this a little clearer. So times 2t. And then for Ida, we have AI equals 2,000 times 1 plus 7%, which is represented by 0.07, and divided by 2, and then we have N, which is also 2 for both, and then we have T. So here we set AH equal to AI, and we'll get the following. So we'll have, let's say AH equals AI, and we have 2,800, 1 plus 0.0596 divided by 2, 2t. And then actually, we can just calculate what this is using our calculator. So 1 plus 0.0596 divided by 2, that will give us 1.0298, and we'll set that equal to 2000. And then we can also calculate this value. So 1 plus 0.07 divided by 2 is 1.035 to the power of 2t. Okay, so now we divide both sides by 2000. So essentially you want to take the 2000 and 2800 and put them on the same side. So we'll get 2800 over 2000. And then we'll move this to the other side by dividing it by both sides. So this gets eliminated on one side. So we'll have 1.035 to the power of 2t divided by 1.0298 to the power of 2t. So because there's 2t on the bottom and the top, we know we can write this as all of it to the power of 2t. So now I'll move this to the top. So now we have 2800 divided by 2000, and that will give us 1.4. And that will be equal to 1.035 over 1.0298 2t. So to solve for the exponent, we have to take the log of both sides. So we know log 1.4 equals 2t log 1.035 over 298, sorry. And then we isolate for t, so we have, we'll say t on the right side. So let's keep t on the right side here for now, so it's a little more clear. So we'll say t equals, and we'll divide everything to the other side. So we'll divide by 2 log to the 1.035 divided by 1.0298. So we'll have log 1.4, which was already on the left side. We'll divide by 2 log 1.035 1.0298. And then we'll end up with t equals, so this is just a matter of plugging in to our calculator. So we have log 1.4 divided by 2 log 1.035 divided by 1.0298. And then we'll get approximately 33.4 years. So, knowing this, this kind of answers our question, after how many years will IDA's investment be worth as much Harry? So you can say after 33.4 years, IDA's investment will be the same as Harry's. So to double check this, we can go back up to our original equations. We can double check this by plugging in 33.4 into this equation and this equation. And we can see what values we get for AH and AI. So I'll just calculate this down here. So if you plug it into your calculator, you'll get AH will equal 19909.1, and then AI equals 19908.8. So I've already done this, I've already plugged these in. So you can see that these numbers are very close. The reason they're off by a little bit is because this was an approximation, because there was more decimal places over here, but I just didn't write them down. So these two are essentially equivalent when 33.4 years has passed. So both their investments are the same. So there's no PDF attached, so no solution attached. Incorrect. Actually, the correct answer is 33.4